Good day guys, today we are going to learn about force. What is force? We will say about it, but let's see how we feel it. Somebody hits you, you will get pain. That's a force. You are sitting on the bench, you are applying some force on the bench. We are attracting each other. Right now you are sitting at your place and I am standing at my place, and we both are even attracting each other with some force. That is known as gravitational force. So, in every place in nature, in space or in this world, there exists some force. कुछ ना कुछ force है. Force क्या है? उसको देखेंगे. उससे पहले हम एक सिचुएशन देखते हैं कि यहाँ पर हमारे पास एक ऑब्जेक्ट है, उसको v वेलोसिटी से ट्रेवल करता है. Now, Aristotle, हमारा साइंटिस्ट, he would say that it is natural for this body to stop. ये बॉडी आराम से स्टॉप हो जाएगी, so it is natural for it. Apple is falling down, its velocity is increasing, so it is natural for apple to get its velocity increased and finally to get stopped. But Newton, he said, it is not natural. This process is not natural for this body. It is not natural for this to stop. ये natural नहीं है. Natural क्या है? Newton said it is natural for body to continue its motion. ये motion में रहेगा. अगर motion में है तो, अगर rest पे है तो rest पे रहेगा. From this statement, he concluded the first law of inertia, the first law of motion. That is what? If anybody, if it is at the state of rest or at the state of motion, it will continue in its motion until and unless a force is applied. So जब तक force नहीं लगेगा तब तक वो बॉडी ना तो स्टॉप होएगी, अगर चलती है तो रेस्ट पे है तो मूव नहीं करेगी. So what is happening here? Here हमें बाद में पता चला there is a friction force that stops it. तो Aristotle यहाँ पे गलत हो गया. तो from this हमारा फर्स्ट लॉ हो गया. न्यूटन ने फर्स्ट लॉ दे दिया, that is also known as law of inertia. Now what is this inertia? Inertia is the property of the body by virtue of which it resists the change in its state of motion. अपने स्टेट में, मोशन का स्टेट में, रेस्ट या मोशन, दोनों को अपोज करती है. Like if there is a heavier body, it will have more inertia, it will oppose more. If you are heavier, you will oppose more. If you have less weight, you will oppose less. If somebody is pulling you, and if you are heavier, then he will have a hard time pulling you. And if there is a lighter guy who is having lighter weight, so he will be pulled easily. So inertia is the property which resists the change. Okay. So now let us see one more situation. What will happen, or what is happening here? The object's velocity has increased. It has increased from v to 2v. There would be some force. कोई force होगा जिससे इसकी velocity change होगी, because according to Newton, this is not possible कि अपने आप velocity change हो जाए, अपने आप state of motion change हो जाए, ऐसा नहीं हो सकता. तो there would be some force, but कहाँ होगा? किस side होगा? Direction क्या होगा? So direction of the force is in the direction of change in the velocity. Velocity का direction क्या है? Velocity का change in direction क्या है? From v to 2v, so the direction of change in velocity is in this direction. So that's why the direction of force is in this direction. Force का direction भी यही होगा. Okay, let us see another example. If the velocity of the object earlier is v and finally it is 0, in which direction force is acting? So we have to look for the direction of change in velocity. Velocity is changing from v to 0. That means direction of change in velocity is in the backward direction. So the force will be acting in the backward direction also. So this time force direction is in backward direction. Now let us see another case. Okay, now the velocity has not changed. Earlier situation, now further we have the same velocity, but here what we have, the direction has changed. So can we say that there is a force? Because the value of the velocity is same. Because Newton said that the velocity should change. I am asking the question, is the velocity changing? I will say yes, the velocity is changing. Why? Because velocity is a vector quantity. If the direction changes or the magnitude changes, so that means velocity is changing. Here the magnitude is remaining constant, but the direction has changed, so there is a force acting on it. But in this direction, we have to look for the direction. So in this case, we have to do one more thing to find out the direction. We have to find out the direction of change in velocity. For that, we have to subtraction of vectors. As this velocity is a vector quantity, so we have to perform subtraction of vectors to get the direction of change in velocity, and in that direction force will be acting. So finally we know that if the velocity changes, there might be some force acting on it. But what is the value of that force? वो value क्या है? What is the magnitude of that force? Newton said that force depends upon many number of factors. Like I earlier said that if you are heavier, then we have to apply larger force to pull you. That means your mass is the one factor. So force is directly proportional to m. What is the second factor? Second factor is acceleration. Now what is acceleration? Acceleration is the rate of change in velocity per unit time. So force depends upon acceleration also. Change in rate of change in velocity or change in velocity per unit time. So what the magnitude of acceleration gives us? It tells us how fastly the velocity is changing. Like अगर हम एक बॉल को स्ट्राइक करें वॉल पे स्ट्राइक करने वाली बॉल की काफी वेलोसिटी थी, लेकिन स्ट्राइक करने के बाद वेलोसिटी एकदम डिक्रीज कर गई. द चेंज, देयर इज अ लार्ज चेंज इन द वेलोसिटी. अगर एकदम से कोई बाइक 0 वेलोसिटी से 50 वेलोसिटी पे पहुंच जाती है, देयर इज अ लार्ज चेंज इन द वेलोसिटी. सो एक्सेलरेशन इज दैट वैल्यू व्हिच टेल्स अस how much increase is there in the velocity, how much change is there in the velocity. So if there is a large change in the velocity, acceleration is large. If there is a less change in the velocity, the acceleration is less. Now the ball example, if you are throwing a ball, velocity gets reduced to 0 after striking the ball, then that means there is a negative acceleration. And negative acceleration को हम deceleration भी बोलते हैं. वेलोसिटी डिक्रीज होगी तो deceleration, इंक्रीज हो रही है तो acceleration. From these points, Newton concluded that there is a second law I should give, that is F is equal to ma. From these 2 points we said F is equal to ma. Mind that A and F are vector quantities. Now further, force, acceleration, we all know this, but there is one more factor on which force depends, that is the momentum, the change in momentum. Force also depends upon change in momentum per unit time. Now what is momentum? Momentum is the product of mass and velocity. into V. But what we are looking for? Change in momentum. So change in the product of mv upon time is our force. There are two cases possible here. One, if the mass is constant. Other, if the mass is variable. If the mass is constant, that is usually happens. Your mass is not changing daily, and that you eat and you just go to bar, and that's the simple process. There's not a big change in your mass, or like your table, its mass doesn't change daily. Okay, it's a regular mass, fixed mass. So we have regular bodies, we have bodies whose mass is fixed. So these are the general cases. Okay, so we will first take the first case, mass is constant. So what we will get, mass is constant, so m into change in v. So we will write it like this, upon time dv. This represents a small change in v, dt represents a small change in time. So m dv by dt, and this is change in velocity per unit time. This can be represented by a acceleration. So that was the second law. Okay. So force depends on change in momentum per unit time, and finally from this also we get the second law, m is equal to m. Okay. What will happen if the mass is not constant? It can happen, and this is the case of rockets. In rockets, fuel burns. The mass decreases. Mass continuously decreases because the fuel burns. So we have to consider the complete change of the product, change in mv upon time. And one more thing he said, what? That all these laws are applicable only for point charges. Sorry, point masses. So point masses means small points, those objects whom we can consider as points. Just say you are not a point right now, or you may be a point. Let us see कि किसको हम point consider करें और किसको नहीं. Suppose करते हैं कि यहाँ से एक object चला, इसके साइज हम 1 मीटर क्यूब ले लेते हैं 3D में, and then इसकी लेंथ हमारे पास 1 मीटर हो गई. He goes to a distance of 100 meters. With respect of 100 meters, this object is like a point. So we have to check how much distance it is covering. So हम कितने डिस्टेंस के अंदर हम अपना लॉ लगाना चाहते हैं, हम कितना बड़ा मोशन को स्टडी कर रहे हैं, ये हमें देखना पड़ेगा. बट यहाँ पर तो हम इसे पॉइंट मास कह सकते हैं. बट अगर it is covering 2 meters, so I will not say that this is a point mass. So we have to see with what respect you are looking. यहाँ पर ऑब्जेक्ट का साइज एंड यहाँ पर डिस्टेंस कवर्ड का साइज हमें देखना पड़ेगा. ओके, सो these laws are applicable for point masses. But what will happen if the mass is not point?